Hey again, math class. Okay, so we're still talking about dividing fractions. And so in the last video we saw that a lot of things with multiplication stay the same. It's just with that added step of always flipping the second fraction, the second term in our problem, the one that sits behind the division sign. In this video, we're going to talk about what to do with mixed numbers. And it's actually really simple because it's exactly the same thing as what we did with mixed numbers when we were multiplying them. We're going to turn them into improper fractions. Okay, so let's do that. 4 times 3 is 12, plus 2 is 14. My bottom number is going to stay the same, okay? So now this guy, he's my second term, right? My second fraction. So I'm going to flip him upside down. And then once I flip him, then I'm going to multiply. I'm going to change my sign, my operation sign from division to multiplication. And so again, at this point, I can cross-cancel anything I want to, right? Well, in this case, both of these numbers are factors of the numbers up top. So 2 is a factor of 14, so I can divide 2 out of both of these guys. 3 is a factor of 9, so I can divide 3 out of both of these guys. And then I just multiply my new numbers, right? 7 times 3, 21. 1 times 1 equals 1. And so again here I have a number over a 1, which means that it is a whole number. So I could say that 4 2/3 divided by 2/9 equals 21. Let's look at another example, okay? In this example, I have a mixed number in the second spot. So not only do I have to convert it to an improper fraction, but then because it's the second guy, I have to flip it. And so when this occurs, let me show you what I do. The first thing I do is recopy my problem, creating my new improper fractions. I leave this the same, okay? 5 times 5 is 25, plus 3 is 28. Bottom number stays the same. I'm going to leave it as a division problem for just a second longer. 3 times 21, or 3 times 7 is 21. I always do that. I look at a problem and say the answer. 3 times 7 is 21, plus 3 is 24. My bottom number is going to stay the same. So when I have two mixed numbers, I always just do one thing at a time, okay? And that's mainly because if I tried to convert this in my head and then flip it, the chances of me writing it down incorrectly are pretty high. So that's why I always write it as improper fractions first. And then I come down here, this guy's going to stay the same, and then I flip it and convert my operation symbol to a multiplication sign. Okay? So again, anything I can cross-cancel here? Well, I can take a 2 out of both 28 and 24, right? Can I take anything bigger out of there? Oh yeah, I can take 4 out of those, can't I? 24 divided by 4 is 6. 28 divided by 4 is 7. Look at that. And now I can't do anything this way, right? Because those are both primes. So the only factor they have in common is 1, and that doesn't help me. It would mean that they stayed exactly the same. So I'm just going to leave them, and I'm going to multiply. 7 times 7, 49. 5 times 6 is 30, okay? So now I have my answer. I got to ask myself, let me move that over there. I got to ask myself my two questions. Question 1, is it a proper fraction? And my answer is no, it's not, right? The 49 is larger than the 30. So I have to come up here. I'm going to do 30 into 49, okay? I know 30 times 2 is 60, so that's more than 49. It's only going to go in once. So then I'm going to subtract, and I have 19 left, okay? So come down here and I'll write it as a mixed number, 1 19/30, okay? Now I have to ask myself, the second question, is it reduced down as far as it can go? And in this case, look at that, 19 is prime. So the only way that I could divide something out of both of these is if 19 divided evenly into 30, which it doesn't, right? 19 times 2 is not 30. So it doesn't work. So I know that this is my answer. It's reduced down as far as it can go. And I can come back up here and say that 5 3/5 divided by 3 3/7 equals 1 19/30. After all of that work. Let's look at another example, because that sometimes this step, it gets a little bit crazy. So here I have 3 3/5, and I'm dividing it by 1 7/20. Okay, so the first step that I'm going to do is to convert both of these mixed numbers to improper fractions, leaving my division sign in the middle. 3 times 5 is 15, plus 3 is 18. Bottom number stays the same. 1 times 20 is 20, plus 7, 27. Bottom number stays the same. Okay? Now I'm going to flip. Now I'm going to flip this guy. I'm going to change to multiplication, and I'm going to leave that guy exactly how he is. Okay? Now at this point, I can cross-cancel anything that I want. Now, look at that. 5 and 20, they have a common factor of 5, right? I can divide 5 out of both of those. And 18 and 27, they have a common factor, they have a common factor of 3, but also of 9, don't they? I'm going to use 9 because that will cross-cancel me down to smaller numbers a lot faster than 3 will. 27 divided by 9 is 3. 18 divided by 9 is 2. And then I'm going to multiply all my new little numbers here that I created. 2 times 4, 8. 1 times 3, 3. Okay, so now I've got my answer. I have to ask myself my 2 questions. Number 1, is this a proper fraction? And what's the answer? No, it's not, because the 8 is larger than 3. Okay, so that means I got to come up here. 3 into 8 goes how many times? 3 times 2 is 6. And 3 times 3 is 9, so 9 is more than 8. It's only going to go twice. I'm going to subtract. I have 2 left over. So my whole number will be that 2 right there. My remainder is going to be the new top of my fraction. The bottom number right here is going to come straight over. And my answer is 2 2/3. Question 2, is that reduced down as far as it can go? And yes, it is. And I know that because if I'm counting 1, 2, 3, 4, 5, 6, 7, right? 2 and 3 are right next to each other when I'm counting. So that means that their only common factor is going to be 1, and I'm reduced down as far as I can go. So I'm going to come back up here, equals 2 2/3. 3 3/5 divided by 1 7/20 equals 2 2/3. Whew, that's a lot. We're going to talk about word problems in the next video, and then we will practice all of this when you get to class, I promise.